I don't know which screen you are seeing. Okay, this is Zhengchun from Oregon National Laboratory. So I'm going to share something about like a ramp deep neural network training as a service delivered through FunkX. So why do we need this? What's the motivation behind this? So as we know that this experiment facility, especially like light source facility like APS and Slack, they are generating really large data at very high throughput, very high rate, which makes it very challenging to kind of analyze in real time for experiment steering, or even like just to save them to a storage, right? So they have some conventional algorithm to analyze to process the data, but those algorithms probably is very hard to parallelize just because the nature of the algorithm itself, from the latency bound or like irregular memory access. Even if you parallelize that, you can use a supercomputer, and the scalability is not very good, and also you need to stream your data from the experiment facility to the supercomputer center. So what we think is that, can we process this data and near the data acquisition near at the edge, right? So I mean, just for two purposes. One is like for experiment steering, and the other is for like data reduction, right? We just extract whatever information we want from the data and only save that information and ignore the raw data. So what we propose to do is use machine learning as like a surrogate model for like convolutional method. Because of this purpose and build AI accelerator, probably the surrogate model will need more flops, but it still can be much faster, just because the way they are doing the way they are doing computation is more friendly to the hardware. But there is no free lunch. There is the key problem is like we need to update the model like as quick as possible, so that the model can be deployed and used within useful time scale. So another reason why we need to update this model regularly is like imagine that for example the value we measure in practice range from, let's say, -100 to 100, but for particular experiments, we know that machine learning model the performance of machine learning model is heavily depends on the data you use to train, right? Probably the data you train has a particular distribution is very narrow. It's very narrow spectrum, and then the model actually just focused on in a very small range. So that's probably another reason why machine learning model can run faster, because it's more lightweight. But the problem is that we need to update that. Like for example, during an experiment, from their experiment condition will change, from their sample will change. Anyway, like we have some this is our big picture. We have some uncertain quantification on the inference side, basically needed data acquisition. When we notice that there are uncertainty is high, they will trigger like a distributed workflow to update the model. Yeah, there are a lot of reasons why we have a workflow here. Workflow here is like we are going to, because we need to train the model fast as quick as possible. And we know that there are like back several years, like 2 or 3 years ago, there are so many papers about like training image data model in minutes or so. We can also do that, but it seems like we need use some what we call data center AI system. I mean, there are like a Samalova, Cerebral, this kind of system, or DGX. This system is it's very good to train your model, but they cannot be deployed in the experiment facility because of some power supply or cooling, etc. They have to sit in the data center. So they are so the model training part and the inference part, which means that the way you use the model will be geographically distributed. So we have to build this workflow so that we can automatically update the model. So this is the way we realize the workflow. So we can think of this workflow as like two major things. One is like the computation side. The other is the data set, right? Because in order to reach the model, we need to transfer the data from because we usually update the model using real experiment data. We need to transfer the data from the experiment facility to our data center or computing facility, and then train the model. And then once the model is trained, we need to transfer back. So there are like data fabric. And the computation side, for some data, we also need to do some pre-processing so that to make it to be like a AI ready or kind of that, ready for to work as a training data set. So we also need some supercomputing resources. And most importantly, we need to deal with this what we call that DCAI, data center AI system, something like Sambalova, Cerebras, Graphcore type of things. Per person build the AI system or AI accelerator to train model much more rapidly. So for the data side, we just use Globus and Globus data transfer service as like an action provider. And for the computation side, either supercomputer resources or DCAI, we use FunkX to abstract that. The reason is like we have been seeing so many different AI accelerator. Each of them has their own pros and cons. Some of them are good at dealing with this kind of model, and the others deal with is good at dealing with other model. So we do need to, make a decision like on which system to pick and to use, and also depends on the availability, right? It's not a lot of world system, a lot of world resources are on demand. You also need to make a decision based on the availability. So that's why we want to abstract this and to the workflow. Okay, it's just an action provider. It's just what we call serverless, right? And you just supply model, supply data, then you return the model, the trained model. So that's the role of FunkX here. We actually built a demo of this workflow. It's just a very simple 3 components. We use Globus Automate to manage the workflow, and then use FunkX to deal with any scene like related with computation, and use Globus Transfer Service to deal with anything about the file transfer. That's we actually have some comparison. Like for example, if you can actually deploy some kind of like small scale computer near your experiment facility. Like you can deploy several GPU cores, that's definitely possible. So versus like you pay the overhead to transfer the data, transfer the model to a data center and train your model. So because like for example, when we work on this Cerebras and Sambalova, it's so fast. Like on a GPU point you need an hour, but on this AI system you just need a few seconds. So it's just kind of still much faster if you pay for the data transfer part. That's all about what I want to share. Thank you.
Okay, thank you. I don't know if there are any questions on this. I guess maybe I'll ask. I'm kind of curious, just on the not exactly on the FunkX side, but how do you know when the model needs to be retrained? Are you doing some kind of analysis as data is coming to look at error, and if so, kind of where do you do that?
So uncertainty quantification is the key. But this is not a general solution for each AI model or for each application. We need to like handcraft an index or metric to tell us the uncertainty, and then trigger the model updating.
I mean, where do you do that calculation? Is that on the
edge?
Yeah. Okay. Any other
I
questions?
don't know how much time we've got, Dan, but a quick question. So using these AI accelerators, at least from what I've seen, can be a little bit painful. Do you have to adapt the function? Like I know that some of these accelerators, you need to compile PyTorch and stuff differently. So if you have one function that you want to run on Cerebras, Sambanova, later GPU, that's not one function. You've got 3 different functions that you've hand-tuned, and then you pick and choose based on where it runs, do you? Okay.
Yeah, exactly. I mean, even in some particular case, like Cerebras is not actually a function we have to go through system call. So we use FunkX to wrap up system call because they have their own scheduler. They have that so specialized.
Yeah, well, hopefully, I mean, big opportunity there to make that easier, because at the moment that's really hard. Is there any support for containers on any of those systems at all?
Yes, yes. Yeah, they use Singularity actually.
And does that work very well?
Yeah, I would say it's very seamlessly.
You're a positive person, Zhengchun. I think I might find that quite hard, but if you think it's seamless, that's good.
No, it's definitely painful. I mean, to start with, there are learning curve for sure.
Awesome. Yeah, keep us posted on that. I'm really interested to see